Today we're going to learn how to write ternary ionic compounds, both names and formulas. Ternary just means more than two. So they're going to be compounds that are made up of at least 3 different elements. And what that means is there's going to be a polyatomic ion in the formula. Okay, so we're going to start out with how do we write formulas for ternary ionic compounds. So it's pretty much the same procedure as the binary ionic compounds we learned about on Monday. So we still just write the formula in charge for each ion. And then we still balance the charges, okay, doing the crisscross rule. And then all we have to do is recognize if there's a polyatomic ion present. And how we're going to do that is how the name ends. Okay. So if you see the ending ite or ate, ite or ate instead of I'd. Okay. So if you see ite or ate, that should be your clue to look at the back side of the periodic table because you have a polyatomic ion. Okay. There are a couple exceptions. So not every single polyatomic ion ends in ite or ate. Okay. You have a couple exceptions like hydroxide and cyanide. But eventually you'd figure it out because if you kept looking for hydroxide on the front side on the periodic table, would you ever find hydroxide? Okay. So if you can't find it on the front side, it has to be a polyatomic ion. It should be on the back side. And then this time, when we write formulas for the ternary ionic compounds, sometimes we need parentheses around the polyatomic ion. And we'll do some practice problems together. I'll show you when we need parentheses. Okay, so let's write the formula for calcium nitrate. So first we'll just start by writing the symbols. What's the symbol for calcium? Ca. Oh. And what kind of charge does it have? Okay, so calcium, it's Ca with the +2 charge. And then we have the word nitrate. Do you see how it's ending in ATE? Okay, so that's your clue. You need to go to the back side. So 8 tells you it's a polyatomic ion. Okay. So go find nitrate on the back. And then go ahead and look up the formula. Once you find it, someone tell it to me out loud. Okay, so we found it. It's NO3 with a -1 charge. Do y'all agree? Okay, so then from here, it pretty much becomes the same technique. We have to balance the charges. Does +2 cancel out -1? Okay, so we've got a crisscross rule. Okay, so same rule, numbers only, so that 2 will move down and become the subscript on the nitrate. And then the 1 moves down and becomes calcium subscript. I'm going to write the 1 for the moment. So we end up with Ca1. And then do you see how it's NO3? And then we have a 2 there, so now it kind of looks like NO32. Okay, so because we had to add a subscript to the polyatomic ion, you need to put parentheses around the polyatomic ion. Okay. And then now I'm just going to rewrite it without the 1. So we end up with CaNO3, 2. The first one is going to be strontium sulfate. What's the symbol for strontium? SR. What kind of charge does it get? Okay, and then it's sulfate. ATE. What is that telling you to do? Okay, it's telling you go to the back. So you're going to find sulfate on the back side and look up the formula. Okay. Can you all find sulfate? And do you see that it's SO4 with a -2 charge? All right, so we have our charges. What's our next step? Crisscross. Okay, crisscross. So what are we going to get?
Parentheses 4 and 2.
Good. Okay, so we have to add the 2, so parentheses will go around the whole SO4. And then what's the last step for this one? Okay, If you can reduce your subscripts, you have to. Now, pay attention up here though. SO4 is sulfate. When we reduce subscripts, you cannot touch the polyatomic ion. Okay, so that means you cannot touch this 4. So when we reduce our subscripts, you can only reduce the subscripts from the crisscross rule. Okay, does that make sense? If you got the subscript from looking up the formula on the back chart, you cannot change that subscript. Okay. But if the subscript got there from crisscross rule, yes, you can change that one. So this one just becomes SO4. Okay, now let's write the formula for copper 2 sulfate. What's the formula for copper? Okay, Cu. What's the charge? Okay, plus 2. We're getting that from the 2 in parentheses here. And then sulfate, what's that 8 telling you to do? Okay. 8 is your clue to go look on the backside. So what's the formula for sulfate? Good. Okay, what's our next step? Okay, crisscross. What do we get after we crisscross? Cu2, SO4, 2. And then what's the final step? Okay, reduce. So what is this going to reduce to? Good. Okay, are we feeling okay with that? All right, next one, it's sodium cyanide. What's the formula for sodium? Na. What kind of charge does sodium get? Okay. And then cyanide, even though it's ending with "ide," it is a polyatomic ion. Okay. And if you didn't remember that, would you eventually not be able to find it on the front side? Okay. So if you can't find it on the front side, look for it on the back side. Okay. And then once you find the formula for cyanide, someone say it out loud. Okay, Cn with the -1 charge. Good. What's our next step?
Crisscross.
Okay, crisscross. We end up with Na1, Cn1. And do we write the ones? Okay. So we'll just write it as NaCN. All right, and then last one on the page is just calcium acetate. What's the formula for calcium? And good, charge is 2+. All right, and then acetate. Good. Okay, so we have CH3COO with the -1. Okay, so we have our charges. What's our next step? Crisscross. All right, so we end up with Ca1, and then we have CH3COO. And what subscript goes down there? 2. Now you put it as subscript on the polyatomic ion, so what do you need around the polyatomic ion? Okay, you have to put parentheses around the whole acetate. Okay. And then finally, do we write the 1 in the subscript? Okay, so I'm just going to rewrite it as Ca, parentheses, CH3COO, 2. Let's switch gears to naming. So just how do we name these ternary ionic compounds? First, you just have to recognize that there's a polyatomic ion in the formula. And if there's a polyatomic ion in the formula, how many elements will be in the total formula? 3 or more. Okay, so I'm going to say 3+ elements. And what are you looking for that distinguishes different elements? How can you tell different elements in a formula?
Capitals.
Okay, so you would see 3 or more capital letters. Okay, so if you see 3 or more capital letters, that's your like indicator that this is going to have a polyatomic ion in it. Okay. And then it takes a little practice recognizing like which one's the single element, which one's the polyatomic. And then when we write the name, the cation still goes first. The anion still goes second. Okay, so always the plus charge, then the minus charge. So here's our example. We have NaC2H3O2. Okay. How many capital letters do you see? Okay, 4. So that should be your indicator that something's a polyatomic ion in there. And it does take a little bit of practice, but which one of these looks like the single element? Good. So Na is your single element. So then that means that C2H3O2, that's 1 unit. Okay, does that make sense? Even though it's more elements, it's still just going to break off into 2 parts. So a cation and an anion. And then now we just name it. What's the name of Na? Okay, sodium. And then that question you have to ask yourself, is sodium a transition metal? Okay, no. So do you have to put the charge in parentheses after sodium? Okay, no. And then next, the other half is C2H3O2. So that's your indicator to polyatomic ion. Where would you look to find the name of that? Backside. Okay. I'm going to help you for this one. Look, it's the very top one. And this time I gave you the second formula. Do you see how it's C2H3O2 off to the side? Okay, what is C2H3O2? Good, acetate. So then we just put it together, and we just name it as sodium acetate. Okay, we're going to do 2 naming problems together. So our first one is CuClO2. We're going to start with the hard one. Okay. This time, how many capital letters do you see? 3. So that tells you one of these is the polyatomic ion. Okay. Which one looks like it's the single element? Okay. So we can see that we have copper, so that's our single element. So then that means that the ClO2, that's our polyatomic ion. All right, so what is Cu? Copper. Is copper a transition metal? Okay, so do we have to put the charge in parentheses?
Yes.
Okay, I'm going to put parentheses here right now. Okay, so to figure out the charge, we have to look at the ClO2. Okay, so flip to your backside. Okay. We need to figure out the charge of ClO2, which is chlorite. So what is the charge of ClO2?
1 minus.
Okay, so it's a -1. And then the outside subscript is your quantity. So how many chlorites are there? 2. What's 2 times -1?
-2.
Okay. So what does copper have to be to balance that? Okay. So copper is a +2. So it's copper 2. And then what's the name of ClO2? Okay. And then just make sure you're very careful of writing the ite versus the ate. So this one should be chlorite. All right, and then our last one is Na3PO4. Okay. Again, how many capital letters do you see? Okay, 3. So that's your hint. One of them is that polyatomic. Which one looks like it's the solo element? Okay, so sodium is your solo element, which means the PO4 is your polyatomic. What's the name of Na?
Sodium.
Is sodium a transition metal?
No.
Okay, no. So do you have to put that charge in parentheses? Nope. So then now you just look up what's the name of PO4. Okay, PO4, are you finding phosphate? Good. So this one just becomes sodium phosphate.